record. What I'll do is if I
Yeah,
just
because John said it would be interesting to say things like, "Why did you join?"
Yeah, fine.
Yeah.
Well, let's start off then. If you could just tell me your name, what you did, and tell me your name and how you first got involved in this game.
Yeah.
Just hang on for a second. I just want to move that out just so I've got a bit more. Actually, see a bit more what's going on. Okay. Could I get you to just turn yourself around a little bit?
Yeah, sorry.
That's better.
Yes,
that's fine. And if you
sit
just
a
look
bit.
towards me,
Look at you.
that's fine. Yeah, that's lovely.
Yeah.
Okay. Yeah. So if you just tell me your name.
Yeah.
If you just look towards me. If you just keep looking towards me.
Yeah. When you're ready.
Yeah.
Yeah.
Get me ready.
Well, I'm Dave Sims. I'm a chemist, sort of, by training. I did a PhD in polymer science at Manchester University. I came here because one day the director of the establishment came to Manchester University and said, "I'm looking for a graduate to come and work in the establishment." So I said, "Oh, a bit difficult for me because I'm married with a child." And he said, "No problem." He said, "We've got some houses. You can have a house." So hence I came here. Bit strange when we first arrived because there wasn't any set project that we would be put on. So the head of the section said, do some work on the physical properties of polymers. Carry on what you was doing at university. So the first couple of years I set about doing some basic work on the compressibility of polymers. And that was fine, that worked out okay. And then eventually everything was a bit random. You gradually got involved in what was going on. And they didn't know much about rubbers and plastics in MOD, and because I'd been trained in them, whereas the others had only sort of picked it up. So we had lots of problems with things like nylon driving bands for shells. That's one I remember. And then we had problems with rubber dracones for carrying fuel. And we worked on various day-to-day problems, really, rather than any long-term thing. And then I got involved with the chap in the laboratory who was doing polymer synthesis, and I started work on polymer synthesis as well. And we worked on a couple of materials that were potentially binders or new binders for propellants. Of course, in those days, propellants were still pretty much in their infancy. There was the PIB type plastic propellant, but the newer carboxy and hydroxy terminated polybutadienes really hadn't come in from the States by then, so we were still looking at alternative materials like polyurethanes. And so I did some work on the effect of structures of polyurethanes on their properties. So it was all basic type polymer chemistry, polymer physics. And then the man who was running the rubber laboratory retired, or was about to retire, and they offered me his job. So I immediately took up much more technological manufacturing of rubber articles and problems of rubber. And that multiplied quite quickly, and we bought an injection molding machine to look at plastics as well. And with a colleague, we started looking at weathering of plastic and rubber materials. The old section I worked for had a tropical research unit in Queensland. So we were able to send out samples and weather them out in Queensland, bring them back and evaluate what had happened to materials out of doors, which was quite important because, of course, all army materials, we were still mainly linked to the army at this establishment. All army materials spend a lot of time out of doors. So after that, we realised that the effect of making the materials, actually processing them, affected their weatherability. So we started looking at processing and the effects of processing on properties of materials. Then people came to us and said, well, you've got these machines, you can make things. So me being a bit of an expansionist said, yeah, that's good, we'll make them for you. And we started making parts for people. By this time, of course, the section was far too big for the old buildings, and we had a completely new facility built on south site here at Waltham Abbey, where we managed to have, I think, 4 injection moulding machines and 3 rubber presses, an extruder, various compound machinery, basically a fully fledged small-scale production unit. And we started making many parts then. And in fact, it ran on through to the Falklands War. And for instance, during the Falklands War, we made 14,000 2-inch rocket motor tubes in about 2 weeks. And so it went on. And effectively, my section became self-supporting. The money we earned by making things ran the section, which was a bit unusual for a ministry place, who usually depended on handouts or grants or budgets or whatever. And this carried on until about 1984-ish, when gradually it became more and more difficult to get work in, because of course military budgets were all running down. And then the decision was made to close Waltham Abbey. So about 1987, my section and most of the people were transferred up to Summerfield, Kidderminster. Now, that wasn't very good really, because it's very difficult to meld R&D and development people in with a production factory environment. It just, we set them up, I set them up, we got going, but there was a certain reluctance of the factory people to talk to what they regarded as pie in the sky research people. And there were times when we got most frustrated because the production people would carry on doing things the way they'd done them for the last 15 years, which if only they'd had a word with us within a week, we could have solved their problem. But that's, I guess, the way it is. And that carried on until I decided to take early retirement in about 18 years ago, about 1990. Looking back, it was an extraordinarily interesting life, particularly in the later years when we were making things. We didn't know what we were going to be doing the next week, but we were always busy doing something. And we felt we were doing useful things in those days. We've had lots of hilarious moments where we've had Christmas parties, and one of my staff managed to walk across the water pipe over the canal, but unfortunately the whiskey took hold halfway across. He got a bit wet, and we've had many other similar laughable events. They were all good guys, and they were all quite bright, and many of the people from here went on to better things. And that's the way it was.
Excellent. Obviously, the angle that I'm interested in is rocketry.
Yes.
I'm interested in, although you say you weren't involved directly with projects and so on, how expanding a bit on how the work you were doing affected rocketry. I'm quite interested because you were saying about solid propellants and a lot of stuff that was coming over from the States. Some stuff was coming over from the States. And I'm never quite sure, at what stage we really got good, efficient, solid propellant rockets, and how our work tied in with what the Americans was doing. And I don't know whether you feel you can talk about that at all.
We tended to follow the Americans. We had our own ideas as to what we should do. And then, because the major oil companies were American, the products came from America. And they tended to be on sale in America first. So we tended to lag the Americans. We saw what they'd done. And, they had what we called carboxy-terminated polybutadiene as a propellant ingredient. We tried it here. And then they had hydroxy-terminated polybutadiene, which was cheaper, as I understood it. And we followed that as well. We developed our own propellants based on that, and our propellants are successful and they're in use today. But we did get ideas from other places. They weren't all self-generated here. I mean, we spent a lot of time researching things that didn't come into fruition. I mean, like the production of the tubes for the Falklands, Bishopton originally contracted out the production of the ether cellulose tubes to a company in East, were they in East Anglia? Anyway, it doesn't matter where they were. They had great difficulty making them. That's how we got involved. We went down there to help them out, to see if we could help them make them. In the end, we took all the work in-house here. And my section made all the ether cellulose tubes for all rocket motors at the end of the day.
Can I get you to just clarify what it is those tubes actually were?
Well, they're the tubes that go on the outside of propellant to stop it burning on the outside. It's called inhibition. Generally speaking, propellants burn from the inside out. You don't want them to burn on the outside. There are designs where they do burn on the outside, but generally speaking, they burn from inside out. So it's like putting paper on a cigarette. And ether cellulose was very difficult to make reliably, but we could make it easily here. And I think the difference is that we had some good scientists and we had better machinery. And so in the end, we made it all. And we did a lot of things like that other people couldn't do. Or didn't want to do because the quantity wasn't high enough. I mean, if you're making spares for machine guns, which we did a few of, they used to come for batches of 100. Now, no normal company wants to make batches of 100. And say the rocket motors, some of the rocket motors we made little seals for. Well, we don't make many rocket motors. If you make 100, you're doing very well because they're very expensive items. Particularly when they're involved, like some of the Javelin parts, which was an atomic weapon. Don't make many of those. Our involvement, or my involvement in most of this, was in anything that didn't go bang or whoosh. I mean, I ended up as head of, here at Waltham Abbey, as head of chemical engineering. So I had, for instance, responsibilities for ingredients, for propellants, ingredients for explosives. I had the analytical labs, and then as well as the plastics and rubber people, and so it was quite a wide sort of range of things. But I didn't actually handle. I used to do a little bit of work on compatibility of plastics with explosives and propellants. Do you understand what compatibility is?
No, if you could clarify.
Basically, if you put a nitroglycerine containing propellant like a cordite or an EDB in contact with a plastic, very often the plastic would degrade very, very quickly. So the other side of the coin is, of course, that the plastic might well set off the cordite or the EDB. You don't get the same problems, or quite the same problems, with the composite propellants because they're based on a rubbery material anyway. But compatibility was an issue that we looked into for plastics and rubbers. And so there's a huge wide range of experiences I've had over the years.
The sort of work that you did, actually, I mean, in some ways it did allow quite a fundamental change in rockets in this country, didn't it? Because I'm assuming during the Second World War, even things like small rockets that were fired off of aircraft and so on, they would have been powder?
They were cordite.
They were cordite.
Yeah, EDB. Yeah. Extruded. Yeah.
Yeah. And in point of fact, what the work that you did, the sort of small guided weapons and so on, then suddenly they became a new type of propellant, didn't they?
Yes, it wasn't work I did personally, but,
no, but
the work of the establishment, yes.
Can I get you to just talk about that? Just say, the work that we did actually revolutionised propellants.
Yes,
or
I mean
contributed to. Sorry.
Well, it basically, the work that's been done recently has got sort of two two or three different aspects. One is cost reduction, obviously, but use at wider temperature ranges, air carried.
Oh, yeah. It's all right. No.
Are you filming?
Sorry.
Are you actually filming?
Yeah. All right.
It's all right.
It's all
We'll cut
right,
that bit out.
Oh, it's only Mr. Sims.
I tell you what. Sorry. No,
You were saying about how it's changed.
yeah.
Well, the work of the establishment, definitely
Sorry, I was
changed
talking over you
rocketry because,
Sorry. Can I just get you to start again?
Yeah.
I was talking over you.
yeah, the work done here definitely changed rocketry in that the propellants that eventually evolved, that are now in service, are capable of a much wider range of temperatures. Particularly, this is useful for air-carried weapons. We mustn't forget other propellants that were developed at Summerfield. They were a different type to what was developed here. They bought, as I understand it, bought a technology from the States, or the government bought a technology from the States and set up Summerfield as an agency factory to exploit this technology. So we have got several different types of propellants now compared to what we had in the Second World War. I guess the big advantage of the modern rubbery propellants is that they're long-lasting, easily stored, and relatively cheap. All things are relative.
I always think to myself, the liquid rocket boys actually they're a bit of a con really, because all from sort of Werner von Braun's side persuaded all these governments and military organisations they needed these great big liquid fueled rockets. And actually, if you look at it now, liquid fueled rockets play no part at all in military weaponry at all, do they really?
No, there are two big advantages to liquid rockets. A, you can turn them on and off, which you can't easily, almost impossible to do with solid rockets. And secondly, they're totally smokeless.
Yeah.
But of course, if you've got a heat-seeking missile, it will find you anyway.
Yeah. But in terms of a military weapon, unless it is,
they're difficult because they're not easily storable.
And I mean, the ideal thing about solid propellants is basically put a match to them and away they go.
Yeah.
You stick them in a cupboard for
There are some liquid systems that they made storable, but they need some difficult engineering.
Is there anything else you can, any stories, any anecdotes that you can think about when you were here, or anything else that sort of springs to mind that would be interesting to recount?
You caught me on a quick moment, right? I need to think back. It's 40 years, is a long time. I remember, for instance, I think it was Blue Water, where they opened the plant to make the propellant in the morning, and they received the orders that they had to close it in the afternoon because the project had been cancelled. But that's not unusual in military things. But they did actually fill some rocket motors, and they did illegally fire them just to get the design information. It always seems silly to me that the TSR-2 was destroyed without getting all the design information from it.
Crazy.
It was crazy, yes.
Well, I mean, unfortunately, you just look back on so much of what we've done in this country.
Yes.
Since the Second World War, really, we sort of lost confidence in so much stuff, didn't we?
Yeah. I think my greatest triumph was on the a torpedo protective cap, where we bought them from the Americans, and somebody asked us at Waltham if we could make them, because they were about £250 each from the Americans, and we actually succeeded in making them for 50, and we replaced the plastic clips that held it on while the torpedo was underneath the Nimrod with a simple strip of foam, and that worked much better because it took up all the vibrations. The caps didn't work their way off. So I think that was probably our greatest triumph.
I'll stop for a second.